This image depicts 3I Atlas on December 21st, positioned just under 2 astronomical units from Earth. The stars appear as this stack is oriented to the object's movement rather than the background sky. Thus, what remains sharp in this image is the object itself, and it certainly remains sharp. A compact central condensation is present, along with a faint asymmetric extension. While subtle, it is indeed real. Given this distance and exposure time, you might anticipate the structure to blur, yet it retains its clarity. The inset clarifies this further. The glow is not symmetrically centered, it is directed. This is post-perihelion. Although the object is fading, the geometry continues to hold. This frame contains a key detail. The panel comparison spans 4 months. August is on the left, September in the middle, and December on the right. Each frame captures the same object tracked in the same manner under varying sky conditions. The alteration is clear, but it is methodical. From August to September, the signal grows stronger. By December, it fades again, as anticipated. After perihelion, equally important is what does not occur. There's no fragmentation, no sudden flare-ups, no collapsing into the background noise. The central condensation remains compact throughout all 3 dates. Even with brightness fluctuations, the object maintains its shape. This consistency over months is more significant than mere brightness. This frame was taken on the morning of December 22nd, recorded above Hawaii. A different observer utilized a different instrument with a very brief exposure, yet the object remains visible. At this scale and integration time, the focus is not on detail but on consistency. There's a compact glow and a slight asymmetry. It is not a point source, ruling out a background star. And it aligns with the structure observed the previous night. No flare, no unexpected change. Just the same fundamental geometry confirmed. Independently. This level of agreement is more crucial than resolution. This image is from December 19th, when 3I Atlas was closest to Earth. What you see here is not a single photo. It's a compilation of multiple wavelengths combined with contrast-enhancing filters. The structure persists through all bands red, green, and blue. The core remains compact, and the elongation stays aligned. This indicates that it's not merely a color artifact or processing trick. The Larsenina filter makes the following part unavoidable. A strong, columnated feature extends outward from the nucleus on the scale of tens of thousands of kilometers. It points toward the sun and retains its shape. Whatever is causing this feature, it is coherent across different wavelengths. That's the takeaway from this image. This photo comes from the Euclid'S space telescope. Appears decorative at first, is actually a structural view on a galactic scale. This is NGC 646, a barred spiral galaxy, almost 400 million light-years distant. The sweeping arms create a curved, asymmetric pattern, abundant with blue star-forming regions. The bright core anchors the system while the arms outline where gas and stars are actively being shaped. Nearby, another galaxy appears. It looks nearby, but it is not separated by tens of millions of light-years with minimal interaction. If any, this distinction is significant. Euclid doesn't merely capture beauty, it maps how galaxies evolve, bend, and reorganize over time. This single frame represents a preview of a much larger survey to come. This was captured on December 22nd during the winter solstice in Paluto, Finland. What you're observing is geomagnetic activity made visible. Green emissions form the base layer produced by oxygen, excited roughly 100 kilometers up. Above this, purple and violet curtains ascend higher into the atmosphere. These vertical structures are not random. They trace Earth's magnetic field lines as charged particles stream in from space. The timing is critical. Solar wind conditions were favorable, and the protracted polar night provides extended visibility. A human figure offers scale. This is not distant astrophysics. It's space weather interacting directly with Earth, in the same universe, but at a very different distance scale. This image is from the Hubble Space Telescope. The dark streaks cutting across Saturn's rings are known as spokes. They are not gaps or shadows, and they do not last long. Each spoke forms, fades, and vanishes within just a few rotations of the planet. The leading explanation connects them to Saturn's magnetic field. Charged dust grains are briefly lifted above the ring plane, creating these radial features. Timing is significant here as well. Spokes become more common around Saturn's equinox when the sun's angle amplifies electrical effects. This isn't new physics, but it is unusual to see it so clearly. A familiar planet continues to display unfamiliar phenomena. This image was captured by American astronaut Nicole Ray Eyes from the International Space Station. What you are observing is a sprite, not a lightning bolt, but a transient electrical discharge that occurs far above thunderstorms in the mesosphere, approximately 50 to 90 kilometers above Earth's surface. The bright flash beneath it is typical lightning, while the red and violet structure above is the response. Sprites exist for only milliseconds and are triggered by intense electric fields released during powerful storms. From the ground, they are challenging to capture, but from orbit, their geometry renders them visible. This is weather occurring at the edge of space. captured in real time from orbit by a human observer. So, that's today's series of updates. An interstellar object, maintaining its structure. A galaxy sculpted by gravity over hundreds of millions of years. Planetary rings, responding to electromagnetic forces. An Earth's atmosphere glowing at the boundary of space. Different scales, the same physics. Now, I'd like to hear your thoughts. What do you think about today's updates? Would you like me to continue monitoring new images of 3I Atlas as they become available? Share your thoughts in the comments. If you found this breakdown helpful, hit like. If you want to receive the next update as soon as new images arrive, subscribe. We will continue tracking the data.